fellow Abarth owners. My name is Brody Dover, and I've created a suspension setup spreadsheet, and I'll go over using the spreadsheet so that you can use it for your own project. You'll see it broken down into some sections. We've got car information, which details items for weight. We've got some information on the front of the vehicle, spring ratio, and the rear. Spring motion ratio there as well, and the angle correction factor of the spring. And lower down we'll see some front sway bar calculation information and unsprung weight information, and the same for the rear over here. Back up to the top, we see some sections here which concern springs, and a section here which concerns springs but to a lesser rate, and it also includes the stay bar information, which is adjusted here in the first two columns. So on our row number 4 we have the stock configuration, so I'll just highlight that, and we see the 22mm bar in the front and rear, the spring rate 195 pounds per inch in the front, 185 pounds per inch in the rear. That number in the rear comes from Fortune Auto's measurements. New Speed seems to disagree. I leave it to you for which one you would like to use. And over in the next two columns we see the natural frequency, front and rear. The front is 1.57 Hz, 2.25 Hz, and that gives us a ratio of 1.43. The stiffness numbers are here, and that's measured in pound-feet per degree, which is torque, the amount of torque required to twist the chassis on itself for each degree. And we use that information to develop the front roll couple. When you're designing your car, you want to look at the natural frequency design targets to pick your springs. For a dedicated autocross car, you want to pick your springs that give you numbers in the range of 2 to 2.2 Hz. These numbers come from Far North Racing's Autocross Secrets book, or How to Win at Autocross, and they are generally agreed upon for dual purpose street autocross cars. At the higher end of that scale, 2.2, 2.4 Hz, you're looking at more or less a dedicated autocross car. If you're on the street, you should err on the caution of going to a lower 1.8, 2.0 Hz range, just because if you value comfort, the stiffer springs, no matter what damping profile you pick, at some point you're just going to be firm. And whether or not you can deal with that firmness, no matter if you design it in flat ride or not, it's just going to be unbearable. So if you don't want to impact stock ride quality, changing springs can improve ride quality, but I would generally go with better dampers. So with stock we actually have a low natural frequency in the front. This number is sort of something that I expect that to be the case. I expect to see a 1.5 Hz number. In the rear we have a very high natural frequency, and that gives us a ratio of 1.43. We want to see something in the range of 1.1 to 1.2, and that range is the range for flat ride. Flat ride gives you the perception of good ride quality despite using stiff springs, and it's a technology feature, I suppose, or a design ideology that was created in the early 30s and 40s by Ollie at Rolls-Royce and General Motors. And he found that having the front tuned to a slower frequency than the rear allowed the car to really balance out how it handles bumps and how it controls, or how it has a tendency for a controllable slide in lateral weight transfer. So we like flat ride, and we should build in flat ride. So if we were doing an autocross build, I have an example here, we could increase the front spring rate to get our 1.95 hertz range, leave the rear springs the same, or leave the rear spring rate the same, disconnect the front sway bar, and leave the stock rear torsion bar. And that'll do two things. It'll give us flat ride of 1.15, and it'll give us an oversteer 10C for front roll couple. Now if I plug in the front sway bar again, you see the front roll couple jumps to 70%. That is heavy understeer. And you can start sort of understanding the compromises of the car with such a big difference in the weight in the front as compared to the rear. So let's go ahead and go with an ST torsion bar, 25 millimeters, and we start getting a reasonable amount. If you're a beginner driver or someone that hasn't competed in autocross for a long time, you might want to look at the ST bar. It has some tendency to oversteer, but it's not going to overwhelm you. And if we go up to 28 millimeters, which is the sweet spot if you keep the front sway bar, you get a beautiful 56%. And that's going to give us a really mild oversteer, keeps things controllable, and increases our roll stiffness about 2 times compared to stock. So we're rolling less, we're introducing some oversteer, and we're getting flat ride. So if you can keep the stock spring rate in the rear, you can increase the front spring rate, then you should have a car that is in the ballpark for the optimal setup. Outside of this, you're looking at damping rates, and you are looking at suspension alignment. But at least we know that our bars and our springs are where they need to be. So that's my quick summary of the spreadsheet. I hope you enjoyed it. And if you have any questions, feel free to add it to the video or add it to the suspension thread, and I can put on another video explaining things in more detail, or I can link you to another video which will help explain some of the points that I talked about. Thank you very much.